In this lesson, we're going to solve an equation that has got complex solutions. We are given that 3i is the root of the equation 3z cubed minus 5z squared plus 27z minus 45 is equal to 0, and we must find the other two roots because you can see it's to the power of 3, so we expect to have three solutions. We know that if the coefficients of the variable in an equation like this that involves complex solutions, if all the coefficients are constant terms, then the solutions are going to occur as conjugate pairs. So for example, if z is equal to a plus bi is a solution to this equation because all the coefficients are real numbers, then z star, which is equal to a minus b I, is also going to satisfy this equation. Now we are told that z is, in this case, z is equal to 3i, then z star for this specific case is just going to be the negative aspect. So if it's not clear for you, this current question that we have here is z is equal to 0 plus 3i, so the real part is equal to 0, so z star will be equal to, you negate that part, so it's become 0 minus 3i. So the first two solutions that we have is that z is equal to 3i and z is equal to minus 3i. Now, to reconstruct the factor that gave rise to this solution, I'm going to do this here and say the factor is z minus 3i is equal to 0, and the other one is z plus 3i is equal to 0. So these two here will satisfy this given expression. Now we're going to try and multiply this out, these two factors here. So we'll take z minus 3i multiplied by z plus 3i. Because they satisfy this polynomial here, they are factors of that polynomial. So it follows that if I simplify this, I'm going to get z squared. You can check that this gives you z squared plus 9. Okay, so this is also a factor of this given expression here. Now, if I were to multiply this z squared plus 9, I'm going to try and divide it into this polynomial there. So if I divide that z squared into 3z squared, you're going to get 3z. Okay, if you're unsure of how to divide this, you must have a look at one of my videos that deals with the synthetic division of polynomials, and you can just brush up your knowledge on that. But this is to the power of 1, so it means that the next term is going to be a constant. So I'm just going to call that constant, let's call it b. And this should be identical to the 3z cubed minus 5z squared plus 27z minus 45. Now, by comparing coefficients, you can see that this term here, the z squared minus times by the 3z squared, will give me 3z cubed. I'm looking to find b, so I'm just going to compare coefficients of the terms, the constant terms. Now if I multiply this one here, 9 multiplied by b, on the left hand side the term, let me just say here terms, or terms in z to the power of 0, this is just a constant. If it's term to the power of 0, so on the left hand side it will be 9b is equal to, the constant term on the right hand side is equal to minus 45. So I'm going to divide that by 9 on both sides, so it tells me that b is actually equal to negative 5. Okay, I'm going to carry on this side of the screen, and so it follows that this other factor here that we're trying to work out is 3z minus 5, because we just found b to be equal to that. So this polynomial is like this: z squared plus 9 is equal to 3z cubed minus 5z squared plus 27z minus 45 is equal to 0. So solving this middle part here is the same as solving that part because we factorized it. This expression is simply equal to this factor form here. So it follows therefore that 3z minus 5 is equal to 0, or z squared plus 9 is equal to 0. Okay, so if I solve this linear equation in z, it means that z is going to be equal to 5 over 3, And here I'm going to get z squared being equal to negative 9, so z is equal to plus or minus the square root of negative 9, which is equal to plus or minus 3i. Okay, so the question required us to find the two other solutions. Therefore, z is equal to 5 over 3, and or we'd been told that z is equal to negative 3i here already. So the one that we are looking for is minus 3i. So those are the other two solutions that we were meant to find.